Hi everyone, welcome back to my channel. So today I'll be going through Marymount Convent School P4 End of Year Exam Paper 2023. So this paper, right, just take note for the section A, which is the MCQ, okay, this is still a 56 mark. So there's still 28 MCQ, okay. So I believe that with the new change in syllabus and there's a new change in exam format, right, this component, right, will now change to, as of 2025, okay, right now this is the time it will change to 60 mark. So the MCQ will be 30 MCQ. Each MCQ will worth 2 marks, okay, which I believe because this changes has been reflected in this year's P5 as well. So that means what happened in your section B, okay, which is the open-ended question, it will change to 40 marks. So we are now back into the era where we have the 60-40. So this is a time where I think it was a time where the exam format is very close to the PSLE back in 2016 or 2015, if I could recall it. So this may or may not be a good news. Some people see it as a good news because we have the MCQ with a higher percentage. So some of them feel that it's easier to score, so they might gain an advantage because of this new exam format. So let's begin for this part. Okay, question number 1. Which of the following is a non-living thing? Non-living thing. So just recall that living things will need air, food, and water to survive. Then living things can grow, respond to changes, reproduce. But non-living things do not any of these. Okay, they do not need any of these. So number 1 is a snail. Okay, the snail of course is a living thing. It grows, it moves around. Therefore, we don't select. Okay, if it's a living things, we don't select. Non-living thing, then we select. Okay, this is a table. Of course, table will be a non-living thing. The table don't need air and water to survive. It cannot move, it cannot grow, it cannot respond to changes, it cannot reproduce. So answer is number 2. Of course, the mushroom over here and the cat is a living thing. They can do all of this. They can do all of this. Okay. The diagram below shows a wall hook that is used to hang object on the wall. Then they ask you, metal is being used. Okay. Because matter is what? Okay, all these they are all correct. Okay, correct meanings, right? What matter is waterproof, matter is inflexible. Okay, matter can conduct heat very well because we call it a good conductor of heat. Okay, matter also is opaque, it does not allow light pass through. Okay, but in this case, right, this question you have to look very carefully. We choose to use matter to make a hook because of what reason? Okay, we must choose a specific reason that is to achieve the purpose of this, to make a hook. Okay, and the answer is number 2. Okay, why? Because over here the matter is inflexible, so that when we hang an object on it, it will not bend. Okay? It will not bend. Okay, and then it will help us to ensure that the object stays on the hook. That's why we choose metal because of these reasons. Okay, and we cannot choose rubber. Okay, rubber, it is flexible, and we hook anything of it, it will just drop off. It will not help us to fulfill the purpose of this object that we want. That we want. Okay, so our answer for this is 2. Okay, so for this, which of the following has a fixed shape? So when we talk about fixed shape, right, it means the object must exist as a solid state. Okay, solid state. So in this case, we have to choose something that is solid. Okay, so let us go through one by one. Okay, air, it is a gas. Okay, it does not have a fixed shape, so that's why we don't choose it. Oil is a liquid. Same thing, it does not have a fixed shape. No fixed shape. Okay, it will take the shape of the container. That's why we don't choose it. Rock, yes, it is a solid. It has a fixed shape. So the answer is number 3. That's why we choose number 3 for this question. Okay. Last thing, we don't choose shadow because shadow in this case, right, it is a non-metal. Okay, and it does not have a fixed shape. Okay, why? Because the shadow can change the shape depending on the position of the object to the light source. So you can kind of change it. So in this case, shadow we will not choose it. It's the most illogical option over here. Okay, that's why we will choose number 3, which is a rock. Okay, so number 4, this question is on life cycle. Life cycle. Okay, Trina makes a following observation about life cycle of an animal. So this animal got 3 stages. The young don't look like the adult. It does not resemble like the adult. So which animal is this person observing? So basically, you must choose the animal that fulfill these 2 criteria. 3 stages. The young don't look like adult. Basically, this is the key idea. And I've extracted this from the P3 textbook on life cycle. You can take a look. It should be somewhere between 86, 80 plus pages. Just look at it very, very carefully. So over here, we got the first one, which is a frog. This is the first option. So the frog, right, the egg, young, adult. Okay, so 3 stage, definitely it fulfill. Does the young look like adult? No, it does not look like. So this must be the correct answer. The young don't look like adult. So straight away, number 1 is the correct answer. Okay, so we take a look at the rest. Okay, bitter. Okay, bitter got how many stage? You look at it, 1, 2, 3, 4. 4 stage in life cycle. Okay, so this one got 4 stage. Okay, and even though the young really don't look like adult, but we cannot choose because why? 4 stage. That's why we don't choose it. Okay, how about chicken? Okay, chicken got 3 stage also. Okay, 1, 2, and 3. But do you realize the young look like the adult? That's why we don't choose. Okay, that's why we don't choose this as well. Last one is your grasshopper. The grasshopper, the egg, young, adult. Okay, 3 stage also. Okay, but the young look like the adult. Okay, they resemble. Okay, they does look like based on that picture. Okay, can you see? Take a look. Okay, it really looks like each other. Okay, that's why we don't choose it. Okay, the key for this, right, usually any insect that has a 3 stage life cycle, insect. Okay, the young will look like adult. Okay, that's for insect. And the 2 insect will be your grasshopper plus your cockroach. Okay, these are the 2 insects that you need to know. Okay, so in this case, right, for life cycle, there's actually a specific animals that you need to know, and there are 7 of them. 7 of them. Which are the 7? Chicken, cockroach, frog, grasshopper, beetle, butterfly, mosquito. These are the 7. Okay, it is being laid down in the MOE document over here, which I put a link over here. You can take a look. It's page 42. Okay, this part you really need to know, and every time when you come across life cycle question, right, these are the things that you can compare. Okay, you can compare the number of stage 3 versus 4. Okay, whether the young can undergo molting. Okay, only insects undergo molting. In this case, it means it will shed off its exoskeleton. Okay, and insect, the outer covering is exoskeleton, so it must be done by insect. Okay, the last one, the third one is whether the young look like adult or not. Okay, so within these 7 animals, right, there are some that will look like, there are some that will not look like. Okay, the clue is any animals with 4 stage life cycle, right, the young will not look like adult. Okay, any animals with 4 stage life cycle, the young don't look like adult. For 3 stage, you have to know each animal individually. Okay, for 3 stage, there are 5 of them. There are 4 of them. So sorry, yeah, there are 4 of them. So you need to know which one look like adult, which one don't look like adult. Okay, and the last one, where they live. Okay, where's their home? Okay, habitat is means the word habitat, right, is a big word, but it just means where they live, where's their home. Okay, so whether they live on land, they live on water, or they live on both on land, or whether part of their life cycle live on land only, part of it live on land and water. So these are things that you need to know, and where to find them. Okay, take a look at this P3 textbook, page around 80 plus. Okay, they discuss each animal very in depth, very detailed. So just read up on this part on your own. So let's go to question number 5. So study a diagram below. Okay, so we want to know what is Q, and they give us 2 things. Okay, can it make its own food? It cannot. Okay, no. Okay, does it have dry skin with scale? So basically, this question is on body covering. Okay, we are asked to choose animal that has a body covering of dry skin with scale, and what could it be? Okay, so first one straight away, and plant must be out, because only plants can make their own food. If you are not a plant, you cannot make your own food. And since we already say no, so it cannot be plant. Okay, actually over here, this should, if this yes, then plant over here. So plant cannot be answered. So you only left with insect, reptile, amphibian. So before you go on to do this question, you need to know the body covering of all the 6 groups of animal. So insect, exoskeleton, out. Reptile, dry skin with dry skin with scales. Yes, that's correct. So this one is a reptile. Amphibian, moist skin. Okay, so out. So what are the other 3 groups of animal? What are their body covering? So just a quick revision. Birds feather, mammals hair or fur, fish is scale. Okay, so notice reptile dry skin with scale, fish is scale. Okay, so there's a difference between the the body covering of a fish and a reptile. So just be careful about this. So the answer over here is 3. Okay, the answer over here is for this is 3. So let's move on to question number 6. Which of the following is not a heat source? Not. So that means if the option is a heat source, you don't choose. Okay, heat source, don't choose. Okay, not a heat source, you choose. Not a heat source, you choose. Okay, so you have to be very clear about what you should choose and what you should not choose. So this is a not question. Okay, campfire, of course, if you put your hand over here, you will feel hot. Your hand will be feel hot because your hand gain heat from the campfire. So it is a heat source, you don't choose. Light up as well. Okay, if you put your hand, actually your hand after a while you will feel hot as well. Okay, so because it gives off light and heat energy, so you don't choose cup of hot coffee. Definitely, because it's hot, you will start to lose heat from the surrounding. If you put your hand beside it, okay, you will also feel hot. Okay, so you don't choose. Okay, winter hat is a heat source. It's not a heat source, so you choose it. It's not a heat source. I repeat again. That's why you choose it. Okay, some of you may think, hey, how come it's not a heat source? When I wear it, I feel warm. Okay, when you wear it, you feel warm, right? It's because when you're wearing it, right? This is a let's say this is a winter hat. Okay, winter hat, because you lose heat slower to the surrounding. That's why you feel all warm. But it doesn't mean that this thing provides heat. Okay, does not provide heat. Does not provide heat. Okay, it just helps you to slow down the heat loss from you to the surrounding. Okay, but it itself is not a heat source because it doesn't give heat to you. Okay, so in this part, so the winter hat, it is wrong, even though when you wear it you feel warm. Okay, so that's most usually people gets this wrong, right? It's because they have this misconception. Okay, so just be careful about this. Okay, for question number 6 is 4. Okay, so in this case, let's move on to question number 7. The reading of the weight scale shows the mass of the apple is what? Okay, so you have to choose between all these, right? You have to look at it very carefully. Okay, so first out, right, when you look at this, right, if you really cannot see it clearly, right, you have to zoom in your eyes to take a look. So you should read it in this way. Okay, so this should be the smaller number. This should be the larger number. Okay, so you should read it in this manner. It looks like you are reading like a clockwise direction. Clockwise direction. So over here is 2. So 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7. So this is 2.7. Okay, so in this case, it should be 2.7 kg. Okay, so the answer is pretty straightforward. Number 2. Okay, so if this part is just have to be careful about it and read it really carefully. Okay, number 8. Okay, in which part of the digestive system is digested food being absorbed into the bloodstream? Okay, absorbed into the bloodstream. So when you're talking about absorption, right, it's only typically done by intestine. Absorption intestine. So let us do a mind map for this part. Okay, absorption, it will be intestine. Okay, so when you see this word, intestine must come to your mind. Absorb means take in. Okay, take in. Okay, where does it absorb into? Okay, it absorbs into the bloodstream. Okay, and the blood will carry these substances to all parts of the body. So intestine. So if it's large, water, absorb water. Okay, if it's small, absorb food. So in this case will be your digested food. Okay, so typically this is actually how you can come up with a very quick mind map to remind yourself. Okay, so in this case, the answer pretty obvious. Number 4 is the answer. Okay, so this 1 and 2 cannot be the answer. Most of the time you are confused between 3 and 4. Okay, large, absorb water, small, absorb food. Okay, so this part you just have to revise this over here if you got it wrong. Okay, that's for number 8 which is 4. Okay, number 9. Okay, the diagram below shows the parts of the plant. Which of them support them upright? Okay, so you have number 1 is the leaf. Okay, the best way is actually to label them. Okay, this one is the flower, and this one is the stem, and this one is the roots. Okay, so in this case, right, you take a look at this. Okay, if you want to match it, okay, with plants upright, it will be this part. Okay, and it will be the stem. Okay, so this is a direct recall. Okay, so this is number 3. 3 must be the answer. Okay, so this is actually taken out from your P4 textbook, page 21. You just take a very close look at it. So these are the 3 main plant parts, 3 main: leaf, stems, and roots. Okay, so the leaf really help them to make food. The leaf can also help them to take in and give out gases, just like our lungs. Okay, and this is done by this thing called the stomata, which is the tiny openings on the leaf. Okay, the roots itself will hold the plant firmly to the ground as well as absorb water and mineral salts from the soil. So the stems, other than keeping it upright, they help to transport water, food, and mineral salts to different parts of the plant. So this is about plant transport system. Transport system, and this will usually typically you will learn it more in depth during your P5. Okay, for this part. Okay, so this part is number 3, no dispute. So what is the function of flower? Basically for reproduction. Okay, flower will develop into fruits, fruits will have seeds, seeds will help them to reproduce. That will complete the life cycle of a plant. So that's for question number 9. So number 10, the diagrams below shows a magnet that is brought towards a steel rod, which is a magnetic material. So what will happen to the rod in this case? So we have 4 options: move up, will not move to the left or right. Of course, in this case, right, if you move a magnet near to a steel rod, right, the steel rod will move in this direction because it get attracted towards magnet. Okay, towards magnet. So in this case, this, okay, over here, this is left. Okay, some students they do not know how to do this question because they do not know left is here, right is here. Okay, that's why they cannot do this question. For this question, right, it's a bit unfair because if you don't know left, if you know the direction but you don't know the direction, this direction is left, right, then you cannot do this question. Okay, likewise, if you know this direction, you don't know the direction, the name of this direction, then you can't do this question. Okay, for right hand side. So this is number 3 lah. So this is actually you need to know the name of the direction. In this case, this is towards left side. Okay, and sometimes it can be quite confusing, which one is left, which one is right, which I get it. I have the same issue when I was a P4 kid. So in this case, this one is number 3. You just have to know it that towards the left, or in this particular direction it is left. Okay, so for question number 11, we have a flow chart that shows some of the animals and how is it being classified. So we have A all the way until D, and we have certain questions that has been given to us: 6 legs, beak, and legs, and then we got to classify them accordingly. So let us go through step by step. We go through A first, then followed by D. So the first part over here, starting point to A. So in this case, right, A must be any animals that has 6 legs. So in this case, it must be an insect. It must be an insect because only insect will have 6 legs. No other groups of animals will have 6 legs. So in this case, if you take a look at option A. Okay, so spider should be out because spider got 6 legs. So we can surely cancel this out. Okay, this one we are not going to choose it. Okay, ants, bee, mosquito, they all are insects. They all will have 6 legs. So 2, 3, 4 could be correct. So now we move on to part B. Okay, it does not have 6 legs. It has a beak. So for B, right, it has a beak but got no 6 legs. Okay, so in this part, let me just write it: no 6 legs. Okay, has a beak. Okay, so obviously this should be more or less a bird. Should be more or less a bird for this part. So for B, right, if you take a look, bat, parrot, owl, right, which one of them is a bird? Okay, which one will have no 6 legs and has a beak? Bat is straight out. Okay, because bat is a mammal, it has hairs outer covering. So we will not choose this. Number 2, we will not choose number 2. So we are left with parrot and owl. Okay, between parrot and owl, right, we will choose both of them because both of them, they are birds. They have a beak. They got no 6 legs. That's why we choose them. See, for C, then now for C now. C is the part that is more tricky. Okay, so let's take a look at this very carefully. So for C, it should be an animal that got no 6 legs. No 6 legs. Okay, let me just redo this. It got no 6 legs. Okay, it got no beak. it can lay eggs. So this is typically how you should be doing for a flowchart, okay, where all the questions, right, speaks about the characteristics of animal that you're investigating. Okay, so C should have all these characteristics. No 6 legs, no beak, can lay eggs. So over here, the crow, right, is a bird. The crow is a bird, so straight away it cannot be chosen because, right, crow is a bird, it will have beak, so we cannot choose this. So straight away 3 is out. So we take a look at 4. Okay, for 4, which is a toad, it is an amphibian. Okay, the amphibian can lay eggs. No legs, no 6 legs. So sorry, no beaks, no 6 legs. So we will choose it. Okay, so of course, between dolphin and lion, right, actually both of them will not lay eggs, both of them will give birth. But in this case, we already say that 3 is out, so the answer should be number 4. Okay, the answer will be number 4 for this question. In this case, number 12. Okay, the table below shows the human body system and their function. Which one is not correct? So basically, not correct, you select. Now let's go take a look at this. So basically, these are the summary page that's taken out from your P4 human body textbook. Human body textbook. Human body system textbook. Human body system textbook. Okay, it should be around page 40. Okay, so it summarizes everything. Respiratory system involves the exchange of gas. Mainly you take in oxygen and give out carbon dioxide. Okay, for this part. Okay, you take in oxygen, give out carbon dioxide. Circulatory systems, you carry substance to different parts of the body. What are these substances? Water, digested food, oxygen, carbon dioxide, and your waste. Okay, so skeletal give the body shape, protect the important parts of the body. Okay, give and protect. Okay, give the body shape, protect the important parts. Muscular help the body to move. Digestive help to break them down into simpler substances. And you need to know the different 5 different organs, right, within the digestive systems, and each of their own function, their function. Okay, so this you really need to know it very clearly, or rather by heart. Okay, so that you are able to answer digestive systems questions. Okay, so you take a look at this. So which one is not correct? So skeletal system give its body shape, correctly match the information. So correct, we don't select. Correct, we don't select. Digestive system break down food into simpler substance. Correct, the word matches as well. So you don't select. Correct, we don't select. Circulatory system take in oxygen. Wrong. Okay, it is a wrong answer, or it is not the correct function. Incorrect function. Okay, so you select. Incorrect function, you select. Okay, so number 3 is the correct one. Respiratory system of score must be correct. They exchange gas, which is this part, involve the exchanges of gas between your body and the surrounding. Okay, so number 4 is the correct function, so you don't select. Number 4 is the correct function, you don't select. Okay, for this part. So for question 12 is number 3 on this part. Okay. Okay, for question number 13, so this is the main concept that is being tested for question number 13 for this part number 2. Okay, living things need air, food, and water to survive. So in this case, right, we have the following setup: A, B, C, D. Each of them have a bread, so all of them got food. Okay, but some of them got holes, some of them have moist bread rather than some of them have dry bread. So we are really investigating the factor for water and as well as air. Okay, where some of the mosquito will not be able to survive because of don't have air or the water. So he checked that he leaves this setup. He checked it after 5 days. Which of the following observation and reason is not possible? Not possible. That means in this case, right, whenever it is possible, which is correct, you don't choose. Okay, whenever that is not possible, which is incorrect, you will choose. Okay, maybe I'll put it here. Okay, when it's not possible, incorrect, you don't, you choose. So sorry, you choose. Okay, for this part. Okay, so let us go through them one by one for setup A. So I'm going to write it in red color for setup A. So setup A got dry bread, so you will have food. Okay, so you have air hole, so that means all of them got air, but you don't have moist bread, so that means no water. No water. So what could have happened over here? What could have happened is that some of the houseflies will have died because due to lack of water. Because as mentioned, living things need air, and water to survive. Okay, so no water, so some die. Okay, so for this part, can you see that A, right? Some of them decreases. Okay, because some of them die. Okay, which is possible. This is possible. Okay, and they do not have water. The reason is they do not have water, which I've listed out over here. This is correct. So it seems like A, right? It is possible. Okay, possible. That means you don't choose. Possible, you don't choose. For B, let's take a look step by step. Okay, for B, you got moist bread. That means you got food, you got water, but there's no hole. So that means there is no air. Okay, no air, that means this one will increase or decrease. It will decrease because lack of air will cause some of the houseflies to die. So in this case, for B, right, it decrease, correct. Okay, they do not have enough air. This is possible. Possible. So don't choose. Possible, don't choose. Okay, possible, don't choose. That means 1 and 2 is wrong. 1 and 2 is wrong. Okay, so for this part, for C, C they got dry bread, not, but there's no moist bread, means there's food. Okay, and there's no hole, that means there is no water, no air, no water, no air. So this part, right, the amount of housefly will actually decrease because due to the lack of water and air. Okay, due to lack of water and air. So you can see this one remain the same and it's very different from this. We say that it will go down, okay, but they say that it will remain the same. So this is not possible. Okay, no, let me write over here. Not possible. Okay, not possible. So this is wrong. Okay, so they do not have enough air and water. They do not have air and water. That is the correct reason. But it will not remain the same because they do not have enough air and water, right? They should have decreased. But over here they write remain the same. So over here, number 3 is wrong. That's why we choose it. Number 3 is this. Not possible, incorrect, we choose it. So the answer is number 3. Okay, this one is not possible. Let's take a look at why number 4 is something that we should not choose. Okay, for number 4, in this case, we got water. Okay, we got water because it's a moist bread. We got food. We also have air. Okay, so we got air and water, right? So it should have remain the same. Okay, that means they will continue to survive. Okay, so this part is possible. They have air and water. This is also possible. So basically for D, right, is possible. That's why we don't select. We don't select at all. So D, which is number 4, is wrong. So we will only choose C. Okay, this part we will choose. Okay, for this part we will choose. Okay, so the answer is number 3 for this question, number 13. Okay, so let's go to number 14. Number 14 is actually quite tricky. Okay, the graph below shows the amount of undigested food. Okay, as the food passes through the digestive system, at which point did the food enter? Not leaving, entering the stomach, entering the stomach. So when we talk about the amount of food that have just entered the stomach, that means it will have left the gullet. Leave the gullet, then enter the stomach, right? So in this case, if I will have this, let's say we have put it in this case, right? And we know that overall, if you eat a burger, right, which is undigested food, right, the amount of undigested burger, right, will slowly become lesser and lesser. Because why? That is going to have digestion happening at here. Digestion happening at the mouth, stomach, and small intestine. Okay, mouth, stomach, and small intestine, they will have digestion. Okay, so in this part, right, the decrease of the amount of undigested food will happen at the mouth, the stomach, and the small intestine. Okay, for this part, the gullet will not have any decrease because there is no digestion. Likewise for large intestine, no digestion. Okay, so you need to know where does digestion happen. the mouth, the stomach, the small intestine, gullet, large intestine, no digestion. So you take a look at this. Okay, let's say we assume that this is just the mouth where we started to eat the burger, and along the way, right, when this burger started to leave mouth, there will be some digestion. And when the burger leaves the mouth, right, there will be some digestion. So you have expected the amount of undigested food to have decreased. So let's take a look at this. So do you realize that point 2, right, is probably this decrease actually is done by the mouth. The digestion done by mouth. Okay, because it will probably pass through the gullet. Okay, and it pass through the undigested food mixture with digested food, right, it will pass through the gullet. Then after that, it will just enter the stomach. So actually this decrease, right, since it's done by the mouth, right, we can say that this part is just entering stomach. Okay, then can you see the second decrease over here, right? This part over here, this part that is more digestion, right? Because the arrow down is much greater, there's more digestion. So maybe this part over here is just leaving the stomach. Okay, so between 2 and 3, right, 2 and 3 is where the digestion within the stomach happen. But since the question is asking you, right, at which point did the food enter the stomach, it should be at point 2. The answer is over here, should be 2 rather than 3, because 3 show further digestion. Okay, and it should not be something we are choosing, because if it shows further digestion, it means that it probably have already completed most of its digestion at the stomach. It's getting ready to leave and enter the small intestine. Okay, so it's going to small intestine. Okay, for this part. And number 4 is probably already leaving the small intestine. This part, leaving the small intestine, because the amount of undigested food is actually quite low for this part. So whatever over here that is undigested, right, will be passed through as waste out of the anus. Okay, for this part. So this part actually quite tricky. So you need to know that the amount of decrease, right, between point 1 and point 2, and point 2 and point 3, and point 3 and point 4, right, it actually shows the digestion, and which one is most likely to be this part. Okay, just enter the stomach, it will be 2. If we're talking about leaving the stomach, I think it's somewhere between 3, or just entering the small intestine could be 3 as well. Okay, so for this part, the most likely answer should be 2 in this case, and you need to be able to know this very clearly to be able to know at which point it represents where is the undigested food. Is it just entering the mouth, leaving the mouth, entering the gullet, leaving the stomach? And these are some of the key ideas that you need to know based on this part. Okay, so you need to be very strong at knowing where does digestion happen, and what will be the amount of undigested food when it's entering and leaving, okay, the organ itself that we are talking about. Okay, so in this case, for question number 14, it should be 2 with this. Okay, so let's move on to this part. Okay, question number 15. Okay, Joshua set up 4 setup. Okay, as shown in the diagram. So we got setup A, B, C, D. Okay, so let's take a look at this part. So we got cupboard in the field, cupboard in the field. Okay, then we got clean garden soil. Then the rest, right, is garden soil. Garden soil, decaying matter, sandy soil. So we have different variables or different environment being used to kind of grow this mushroom. So they say that which of the setup should we choose if we want to test if mushroom needs sunlight to survive. So the change variable over here, the change variable is actually one have the presence of light. Presence of light. That means, right, one of your setup must have light, the other one got no light, while the rest of them remain the same condition throughout, so that you can test this as fairly as you want. Okay, so which will you choose? A and C. Let's break this down once and for all. Okay, so you can see in the cupboard in the field, in this case cupboard, okay, maybe I can take it as cupboard as no light because it's away from the is given in a dark place away from the light source. So A and C, would it be the correct choice? Can you see that one is clean soil, one is sandy soil? So it may not be the best option because the planting material, they are different. Okay, so in this case we should not be choosing number one because the planting material, they are different. So A and D, how about A and D? So let me remove this A and D, A and D. A and D, so both of them, they are in cupboard. So if both of them they are cupboard, both of them don't have light, you cannot test this out, right? So basically A and D is wrong. Because you cannot test the change variable, which is the need sunlight to survive. You need one setup to have it, the other setup not to have it. So A and D wrong. B and C, how about B and C? Let's take a look. B and C. Okay, in the field, both of them have light. Okay, if both of them have light, you also can't test. Okay, in this case, in order to test this out, you need to one of them have light, one of them got no light. Okay, for this part, which is one on in the cupboard, one on in the field. In the field, we take it that there's sun, there's light. Okay, cupboard is being sheltered away, so there is no light. Okay, so B and C is also wrong. So the only answer we left with is for B and D. And let's take a look why B and D is correct. Okay, so B and D, right? So they are one of them in the field, one of them in the cupboard. So this one, there's light, no light. Okay, one of them got light, no light. So this one, they are the same. So same. Okay, they are mushroom. Okay, they are not different things. So this should be the setup we should be choosing. Okay, number 4. Okay, keep everything the same. Only one of them have light, one of them without light. So this should be the best option. For 15 is 4. Okay, let's move on to number 16. So which of the following shows the correct life cycle of a butterfly for this case, right? So in this case, butterfly, you know about 4 stage. Okay, 4 stage life cycle, and each of them shows you 4 stage life cycle. Okay, so it should be from the egg, larva, pupa, then adult. Okay, then the adult back to the egg. Okay, let's take a look at each option. So number 1, egg pupa. Egg pupa should be wrong. This should be larva. Okay, this should be larva. Okay, for this part. So egg adult, also should be wrong. This should be larva because of the direction of the arrow that is pointing. Okay, egg larva, okay, can. Egg larva pupa, then adult. Okay, it seems correct, but you can see these 2 arrows, they are pointing to each other. So this one also wrong because the arrow, they are pointing towards each other. So this part also wrong. So the directionality of the arrow is important when you are looking at the correct life cycle. So in this case, the answer must be number 4. But let's take a look why number 4 is correct. Okay, so we egg, larva, pupa, then adult, then back to the egg. Okay, that's correct, which is what I've drawn over here. Egg, larva, pupa, adult, then go back to egg again. Okay, so in this case, right, a cycle, right, there's no start and end because it moves in the cycle. You can't identify where is the starting point and ending point, but I choose it to be egg because it's the easiest. Okay, because normally I'll recite it as egg, larva, pupa, adult, then go back to egg again. So in this part, right, you can see that 3 is very tricky if you did not see this arrow correctly. Okay, which is the egg pointing to the adult and the pupa pointing to the adult as well. So this part wrong, very tricky. Okay, I know some students may have choose number 3 because maybe because they was analyzing 1 and 2. They already know 1 and 2 is out. So when they are looking at 3, it seems that everything is fall into place, but they forget to consider about the directionality of the arrow, which is an important part when we are choosing the correct life cycle. Okay, so for this 16 is 4. Let's move on. Okay, question number 17. Study the 3 objects below. A bag of cotton and rice are fully filled. In this part, okay, you got cotton, paper, and rice. Okay, the cotton over here is 2 kg, paper is also 2 kg, the rice is also 2 kg. Which of the following statement about the object above is correct? So over here, can you see that the units, they are all the same? So they are trying to tell you that the mass, they are the same. The mass, they are the same. Okay, in this case. So let's take a look at all this statement. The cotton is lightest. No, if the cotton is lightest, right, then in this case, that this should be more or less 1 kg, or there should be less cotton inside the pack. Then this will be the correct one. But it is not. It is already tell you it is 2 kg, so 1 is out. So the paper has the most amount of matter. So this is also out. It's trying to tell you that the paper is the heaviest, but in this case, you know it's wrong because this one is 2 kg. Okay, so they have the same mass as the rest of the items. So 1 and 2 is out. The mass of all the 3 items, they are the same. This is correct. Because why? All of them are 2 kg. Okay, if all of them are 2 kg, they have the similar mass. Okay, so the mass will be the same. In this case, the amount of matter inside them, they are the same as well. So number 3 is correct. Number 3 is correct. Okay, so let's take a look at number 4. The volume of the cotton, paper, and rice are the same. They are not the same. Why they are not the same? Because over here you can see this is the amount of space the cotton will occupy. This is the amount of space the paper will occupy, and likewise this is the amount of space the rice will occupy. If they do occupy the same amount of space, then the picture should show something like this. Okay, the picture should show something like this. Okay, but they are not. Okay, they don't occupy the same amount of space. The volume is different. Okay, so 4 is out. So before we go into the next question, let's talk more about the mass and volume, because this is the most confused concept for P4 students. So what is mass? What is volume? The mass is really the amount of matter in an object. Volume is the amount of space an object occupy in the physical world. So there are 2 different things. Mass and volume, they are 2 different things. So in this case, right, you can have this. Okay, an object that can have a large mass but occupy small volume. In this case, maybe an iron block, a small iron block. Okay, the mass is quite huge. Okay, but the volume is extremely small as compared to an object that has a large volume but small mass. Maybe I can think of maybe cotton. In this case, cotton. Okay, if you manage to have a cotton that is as heavy as the iron block, you realize that the cotton will occupy more space than the iron block itself. Okay, so this is the meaning of volume and mass, and they are very different in nature, or at least they are different in how we actually interpret them. Okay, so likewise for this situation over here, okay, they can have the same mass, they can have different volume. They can have same volume but different mass. Okay, it can happen as well. Okay, so but for this, in short, the answer for question number 7 is 3. Okay, so let's take a look at question number 18. Ali planted an equal number of seeds in 3 jars containing cotton wool as shown in the diagram below. An equal amount of water was added to jar Y and Z. Jar Y was placed in the refrigerator while X and Z were kept in the classroom. So refrigerator, the temperature is very low. Okay, while this temperature is higher, because at least higher than the refrigerator. So this is more or less at room temperature. Okay, so in this case, after 1 week, the seeds in jar Z grew better than X and Y because they had enough watt. Okay, let's compare Z and X. So one of them is in Z and X. Okay, Z and X. So this is moist, this is dry. So Z is moist, so water. This is dry. Okay, so that means Z grow better because they have more water. Okay, this one grow better because they have more water. So in this part, we will choose C. Okay, so then we compare Z and Y. Okay, one is of them is Z and Y. Okay, maybe let me use the blue color. Okay, Z and Y. Okay, one of them is in the classroom. One of them is in the refrigerator. Okay, the temperature here is higher, temperature here is lower. Okay, so we can say that when the temperature is higher, is for Z, right, and they grow better. This symbolizes what? This symbolizes warmth for the seed. Okay, in this case, so in this case, it will be C and D. Okay, for this part. So it's trying to show you that why Z grow better. Z grow better because they have water. Z grow better because it's placed in the classroom. They have water, they have warmth, that's why it grow better. C and D will be the correct answer, number 3. Okay, as we know, and this is the main concept that is being tested for this question is germination of the seeds. Okay, germinations of the seed need 3 things: water, oxygen, and warm. Okay, oxygen is found in the air, which is everywhere, be it the classroom, the refrigerator. Okay, so in this part, we are actually not comparing this. We're comparing this and this for the case of X and Y and Z. Okay, so with that, let's move on to question number 19. Which of the following cause a change of state in matter? What is the change in state of matter? Change in state of matter means the solid become liquid, or liquid become gas, or likewise they can move in the other way around. Okay, the liquid will become solid, and or the gas will become liquid. So this is what we mean by change in state. Okay, for this part. So leaving a dish of water on the table overnight. So if you leave a dish of water on the table overnight, right? Okay, in this part, okay, you realize that when you come back in the morning, right, either the puddle of water becomes smaller, okay, becomes smaller. Okay, that is because, right, the water that exists in the liquid state, right, actually disappear into the air, or it changed into gaseous state. It changed to a gas. Okay, and this process is what we call evaporation of water. Okay, this is something you will learn in P5 next year. But in this case, right, this really show you a change of state. Number one, really show you a change of state. So a very typical example is, let's say you are going to the school in the morning when there's rain. Okay, so when there's rain, right, you will observe that on the floor or on the footpath there will be a puddle of water. So when you go to school, maybe around 7 a.m. in the morning. So when you leave school, maybe about 1 p.m., you realize this puddle of water is no longer there anymore. Because why? The liquid, okay, the puddle of water that exists in the liquid state, right, actually changed to a gas, and it actually become part of the air. Okay, so this is what we mean by change of state, or in this case, evaporation in short. So the answer is number 1. 2, 3, 4 cannot be the answer, because when you're tearing a piece of paper, right, into smaller strip, right, the piece of paper still exists in the solid state, but it's just smaller pieces. Okay, solid state. Okay, so when you're stretching out a rubber band until it breaks, right, even when you have one rubber band break into 2 rubber bands, they are still solid. They are 2 solid rubber band, but they are just smaller in length. So 2 and 3 cannot be the answer. So pouring a cup of water to drink. So when you pour water, okay, when you pour water, right? Okay, when you pour water from a bottle into a cup, okay, into a cup, in this case, the water still exists in the liquid state. Okay, it still exists in the liquid state. There is no change of state in this case. Okay, so number 4 cannot be the answer. So another typical example where you have a change of state is that you have let's say you have an ice tray. This ice tray, you put water onto it. Okay, you put water. Okay, you put into the you put water into it, right? So at first it's a liquid state, right? Then you put in the refrigerator. Then after a while, next morning you take it out, you realize everything will become solid state. Okay, because why? They freeze. Okay, they freeze into your ice cube. Okay, so this is another typical example of change of state. Okay, question number 20. So Adrian got 2 setup as shown in the diagram below. So we have container A versus container B. Container A got 700 centimeter cube, while container B got 500 centimeter cube, and it contains some water of 100 centimeter cube. So he pumped he pumped 200 centimeter cube of air into the container completely using the syringe. Right? What is the volume of air in each container after he pumped the air? So I just want to know what is the volume over here. Okay, so over here, this kind of question, right, the real concept that's testing you is really air has no definite volume and can be compressed to occupy a smaller space. So over here, the total volume of air, right, for A, right, we know that it's 900. Okay, why? Because we have 700 plus 200, right? So but it has been compressed into a space that has a fixed volume of 700 centimeter cube. So the volume inside here will be 700 centimeter cube. Okay, it will not be 900. Okay, it will not be the way that you do in the mathematical class. No, okay, it will be 900 because the air got no definite volume. It's just compressed into a fixed is just compressed into a container that has a fixed volume of 700 centimeter cube. So in this case, 700 will be the correct answer. Number 1 is wrong. Number 4 is wrong. Obviously, 700. It's just that now we are thinking between 500 and 400 for volume of air in container B, right? What will be the answer? Okay, so to recap, A, right, the volume of empty space in the container will equal to the volume of air, which is 700 centimeter cube over here. So for this kind of question, to be able to calculate the volume of air, right, just take the volume of empty space within the fixed container. That will be the volume of air that we're talking about, no matter how much is being pumped in or no matter how much is being removed. Okay, for B, right, for B we have water, right, in this case, and even though we pump in 200, right, the volume of air over here, right, will just be this amount. Okay, because this will be the volume of empty space, okay, over here. Okay, for this part, then this will be the volume of air that we're talking about into the container, regardless of whether we pump in or whether we remove. Okay, so the explanation is really this. Okay, for this part. Okay, hence for B, right, we can find the volume of air by taking the total volume of the container, which is 500, subtract away the volume of water only, minus 100. So these will represent the amount of empty space in the container that take up by the air, that's taken up by the air. The volume of air that is pumped into a container will not affect the final volume of air. So the mathematical calculation will be something like this: 100 centimeter cube. So we take 500 minus 100, it will be 400. So over here, 400 will be the correct answer. So for this answer will be number 3. 3 will be the correct answer for this question. Okay, so in this case, don't do it the mathematical way. Don't go and add 200 and put it as 900. No. Okay, the idea is air has no definite volume. It can be compressed to occupy a smaller space, or it can be expanded to fill up a larger space. Okay, if in the case that if you remove the air from the container. Okay, so with that will be question number 20. So in this case 21. Okay, 4 rods made of different materials are coated with equal amount of wax. Okay, trying to tell you that this is a fair test. Okay, at their tip, the rod will place in a container of hot water at 100 degrees Celsius for 5 minutes. The diagram shows the amount of wax melt at the end of 5 minutes, and this is the amount of wax that melt. Okay, and they ask you which one is the porous conductor. Okay, the porous conductor in this case, it will help to slow down heat gain by the wax from the hot water. So in this case, it will melt the slowest. So to be able to answer this clearly, we have to look for the wax that did melt the slowest or did not melt at all. So you take a look. This is the original position of the wax. So P definitely melt, Q definitely melt. If we were to compare this and this and this definitely melt, right? So R did not melt at all. You see, this one did not melt at all. It's exactly the same. So in this case, right, the rod for R will be the porous conductor of heat, because the heat travel very slowly up to the tip to melt the wax. Okay, and perhaps within that 5 minutes, right, the amount of heat that conducted through the rod R was not enough to reach or was not enough to melt the wax in this case. So that's why the melts, right, the wax, right, still remain in the same shape and same size. Okay, it did not melt into a liquid, or it did not melt the liquid state. Okay, for S, definitely it melt a little bit. Okay, in this case, so R will be the porous conductor of heat if you look at the diagram very clearly. Okay, for this part. So with that, let's move on to 22. So 22 is really light versus shadow. Light versus shadow. So one night, Adam walked from point A to point C, passing a lamppost at point B. There were no other light source. So this is the only light source. Okay, so in this case, as he which of the following graph shows the length of Adam's shadow change as he walked from A to C, though he moved from here to here? So over here, right, if you want to clearly know how the shadow will change, right, we have to draw lines. Okay, so over here at this point, right, the shadow, okay, for A, right, okay, the shadow for A, let me just briefly draw it. This will be the length of the shadow for A. Okay, the length of shadow. So if I were to draw a similar person, similar person, okay, let's draw the length of shadow for B. Okay, maybe here. Okay, cover the legs. Cover here. This is the length of shadow for B. Okay, length of shadow for A. Length of shadow for B. Okay, and this is the length of shadow for C. Okay, it's not enough to actually cover this part, so I'll just draw it longer. So length of shadow for C. So can you see that as he walked from B to A to B, right, the length over here decreases. Then he walked from B to C again, the length of the shadow increases. Okay, so in this case, right, very typically, which graph looks shows you that there's a decreasing first followed by increasing. So in this part, this one only show increase, so wrong. This one only show decrease, wrong. So we must look for decrease first followed by increase. So the line must go down, then the followed by the line is going up. So can you see this one? Line go down from highest to lowest. The line went down. So this is decrease. Then over here to here, the line went up. So this is increase. Okay, so can you see it shows you a decreasing followed by increasing trend. So C best reflect what is going on for Adam's shadow. So or rather 3 shows the best of what is going on in Adam's shadow. So the answer must be number 3. For 4 cannot be the answer because this one is increase first, then decrease. This one shows you that the length of the shadow is highest, which is not correct because we already established that the length of shadow at B should be the lowest when the person is directly under the lamp. Okay, for A and C, right, as long as the person is further away from the lamp, the shadow will be much longer as compared to B. So this one definitely is wrong. Is out for graph number 4. 3 must be the correct answer. The diagram below shows a mirror and a ball that is being placed between a light, torch and the screen. So the torch and the screen is over here. We have the mirror and the ball in between. Which of the following correctly shows the shadow cast on the screen? So I have here over here. This is the mirror. This is the ball over here. So over here the mirror, right? Actually, if you cast a light, right, this part, this whole thing, right, over here, this will be opaque. And over here, I choose an opaque ball because most of the ball are opaque. Okay, they block light. So in this case, right, if I were to draw the light and shadow, right, it will look something typically like this. Okay, so the light will hit the mirror and this part over here become the whole shadow zone. Okay, so the shadow that's going to appear over here will take the shape of the mirror. In this case, it will look something like this. Okay, on the screen. Okay, it will look something like this. Okay, because the ball is behind the mirror, right? So it's already in the shadow of the mirror, so it will not actually cast additional shadow, okay, that is on the screen. So in this case, right, 1, 2, 3, and 4, which one looks like this? So the answer will be number 2. Okay, 2 looks like this. Okay, the ball, because it's behind the mirror, so it will not affect the shadow in any way in this case. Number 4. For number 4 over here, you don't see the side, right? It's trying to tell you that this part is transparent, okay, which is wrong. Okay, which is wrong. In this case, right, the mirror does block light. Okay, what could be transparent? Maybe like a clear glass. Okay, in front I put a clear glass, then I have a ball, then maybe 4 could be the answer. But for number 1, in this case is probably this part will allow light to pass through. This part, light can pass through. Light can pass through, but the edge, right, still kind of block off some light. That's why you can see the edge, okay, the shadow of the edge being formed. Okay, for number 3, it's trying to tell you that this is showing you a faint shadow. and the shadow is kind of larger than the ball, right? So it's trying to tell you maybe the object in front is probably a translucent object. Okay, so I'm using the answer, right, to actually kind of think of what kind of object we can actually place in front of the ball so that we can have this kind of shadow. Okay, so but for this, the actual answer should be number 2. Okay, 24, 4 beakers with different amount of water at 30 degrees, so all of them started at 30 degrees. Starting temperature 30 degrees Celsius were heated until they reach 100 degrees Celsius. So all of them it hit 100 degrees Celsius, okay, and that's where the experiment was stopped, okay, using the different numbers of burners. So we only have 1 burner or 2 burner for setup A to D. Okay, so the time taken for them for the water in beaker C to reach 100 degrees Celsius was 10 minutes. So this one took 10 minutes to reach 100 degrees Celsius, and C, you can see that it has a few characteristics. It has 500 ml, which is more than A and B, so it got more water, and you got least burner. Okay, you got more water and least burner. For C, that's the characteristics, or that is the item that is in the setup. Okay, which I managed to pick it up just by the drawing. Which of the following statements is or are true for the above setup? Okay, so for this is actually quite a difficult question in this case. So the water in all the beaker took 10 minutes to reach to 100 degrees Celsius. This is wrong. This is wrong. Why? In this case, right, if you see C, right, C, right, actually should be the last to boil. Why is it the last to boil? Because it has more water than the rest, or it has more water than A and B, and it has the least amount of heat because it only has 1 burner. Okay, so in this case, the relationship, right, for us to establish is that the lower the amount of water, the faster the time taken for it to reach 100 degrees. Okay, because there's less water in there, so you need less heat to raise to 100 degrees Celsius. Okay, in this case, so the lower the amount of water, the faster it will reach 100 degrees. So since C has more water, C will take a longer time to reach 100 degrees. Okay, for number 2, the more burner there are, the more heat source there are, and the faster the time taken for them to reach 100 degrees. So generally, the one that will boil fastest or to reach 100 degrees fastest, right, will be the one that has least water plus more burner. This one will reach 100 degrees fastest. Okay, and you can see that typically which one is the one that will boil fastest? A will boil the fastest, so that means it will take less than 10 minutes because it got less water, okay, and it will have more burner. Okay, so with that, right, all the water in the beaker took 10 minutes, right, straight away is wrong because we know that A will be the fastest and C will be the slowest. So let me write this down. The fastest is actually A. The slowest is actually C. Okay, for B and D, I really don't know because B, right, got least water but only got 1 burner. But C, right, D, right, got 2 burner but you have more water. So it's very difficult to tell B and D which one will boil first. Not possible to tell because we don't know whether the effect of having 2 burner, okay, will allow the water to reach 100 degrees Celsius faster, or the effect of having least water will allow the water to reach 100 degrees Celsius. We can't tell. So in between we have B or D. This one is not possible to tell. I cannot tell whether B or D which one will be faster. Okay, between the both of them. But I know A will be the fastest, C will be the slowest. Okay, because if I were to compare them very equally, A got least water, most burner. C will have more water, least burner. Okay, so that's that is the main thing I'm relying on to tell which one is the fastest and which one is the slowest. Since we know that A is wrong, so A is out. So number 1 is wrong. So straight away, number 1 is wrong because the rest of the option don't have A. Okay, so which of the following statement is or are true about the above setup for B, C, and D? So let's take a look at B. The water in A took the shortest time. That's correct. I already established this. It will reach the 100 degrees Celsius fastest. Okay, because of least amount of water, most burners. Okay, so B is correct. So B is correct, right? So in this case, right, 4 must be wrong because 4 don't have B. That's why 4 must be out. So you are choosing between 2 and 3 only. That means you are deciding whether C and D, which one is the correct answer. Okay, the water in B took less than 10 minutes to reach 100 degrees Celsius. Yes, this is true. Okay, even though I don't know, is it going to be faster than D? Okay, but I definitely I will know one thing, that B is going to be faster than C. So it will took less than 10 minutes. So C is correct. So with that, right, 2 is the answer. D must be wrong. But let us take a look why D is wrong. Okay, D will took more than 10 minutes, so straight away wrong. Because we know that if we were to compare this, right, you got more burner, more heat source, with the same amount of water, it should take less than 10 minutes to reach 100 degrees Celsius. So it should not be, no, this part is wrong, it should be less. Okay, this part is wrong, it should be less for this part. So with that, right, we can kind of do it very systematically if we already know these two relationships. These two relationships is the crucial part for us to know how to evaluate each of the statement. Less water, reach 100 degrees Celsius faster. More burner, more heat source, reach 100 degrees Celsius faster. Okay. Question number 25. So 3 basins of water, X, Y, and Z at different temperature. Okay. Dyson dipped his right hand into basin X over here, left hand into basin Z. Okay. After 1 minute, so he placed here for 1 minute. Okay, 1 minute. He placed both of his hand into Y. Okay, you're going to transfer them into Y. Then he tell you that right hand felt hot, left hand felt cold. Okay, for this part. Then based on the observation, which of the following are the temperature of the water in X and Z? Okay, based on this temperature, which is given to you at 25 degrees. Okay, so first up, if you put your water in the basin of different water for 1 minute, then you're going to transfer them and you have different feelings, right? The temperature of the basin for X and Z will never be at 25 degrees. So 25 confirm out. Okay, because heat, right, always flow from higher to lower temperature. So if you feel hot or feel cold, right, there is heat flow. Okay, so it cannot be at the same temperature. So 25 out. So 25 must be out. So you only left with this one, 50, 50, 10, or in X and Z, or 10, 50 in X and Z. So it's really you are down with 2 options. Okay, which one is the hot water, which one is the cold water? Okay, some typical way that you might think, okay, the one that you feel hot, right, that means previously it must be hot water. Okay, actually this is a wrong thinking. Okay, so in this case, right, if you think about it, when your hand feel hot, when you transfer to Y, right, it means, right, your hand at Y, when you put into basin Y, right, your hand is actually gaining heat from water in Y. So if you are gaining heat from water in Y, right, the heat actually transfer from the water in basin Y to your hand. So let's say this is your right hand. Right hand. The water in Y, right, is transferring to here. So this is higher temperature. So in this case, your hand must be of a lower temperature, higher to lower. So in this case, right, the temperature of your right hand, right, should be at 10. Okay, that means how come your temperature of your right hand is at 10? Because the basin over here is at 10 degree. Your hand, when you dip it, right, you will reach, if you leave it long enough, you reach to the temperature of the water in basin X, because your hand lose heat to water in basin X and reach to 10 degrees Celsius. Likewise, for your hand in basin Z, right? So this is your hand. So I'm going to draw in red color. Okay, your hand. Then this is the water in Y. Okay, water in Y. Okay, this is at 25 degrees, right? So your hand feel cold because why? Your hand losing heat to water in Y at 25 degrees. So the heat is going from here to here. So if the heat is going from your hand to Y, right, that means here must be higher temperature. It must be at 50 degrees Celsius. So over here, this will match with this part over here. So 4 is the correct answer. So what happened is that, right, when he put the water in X and Y, right, where X is at 10 degrees Celsius, Z is at 50 degrees Celsius, right, his hand actually lose heat and gain heat in each of X and Z, depending on temperature, until they become the same temperature as the basin. So when you transfer to the basin Y, right, so for X, which is the right hand, it will start to gain heat because the temperature for the hand is lower. For the left hand, because the temperature is higher, so it will start to lose heat. That's why he feel cold. Okay, so in this case, so yeah, you need to use the idea of losing heat and losing heat or gaining heat, right, to actually tell where is the heat transfer. Then from there you should be able to tell what is the temperature of the basin in this case. So it's a bit quite difficult. Okay, in this case you have to think about how the heat is being flow from your hand to the basin. Okay, in this case, Wei Ming attached a bar magnet of P to a toy car as shown below. Then he held another bar magnet of equal magnetic strength and brought close to magnet P. Then they ask you which of the following setup will help him to move the car in the direction as indicated by the arrow. So basically we have to look at how the magnet is being positioned and where is the direction of the car. Okay, the arrow represents the direction of the car. So for S and S, they are light poles. Okay, the light poles are facing each other, then they repel each other. So the direction should be in this way. So for P, right, it should be facing towards the left side. So can you see that this arrow is facing towards right? So this is incorrect. So one is wrong because that is not where the direction of the car will move. Okay, this is where the direction of the car will move. Okay, so number 2, okay, same thing, they are light poles, so they will face away from each other. So P will move towards the right, Q will move towards the left. So this arrow matches with this arrow. So 2 is correct answer. So the answer must be number 2. Okay. So in this case, let's continue with that 3 and 4. So 3 and 4, right? This for 3, right? This is unlike poles. So then they will attract. If they attract, right, they should face towards each other. So can you see this arrow don't match this. So 3 is out. Okay. So for 4, right? They in this case, if you brought near Q to P, right? So in this case, they will attract to each other. Okay, so in this case, the car will most likely move in an upwards direction, not towards the right. So in this case, this is also wrong. So 4 is out. So basically, you have to use the interaction between the poles that they have been given, right, to identify the direction where the car is moving. Is it in line with what magnet P is showing to you? Okay, so question number 27 is about transparency. Pauline got 4 sheet PQRS made of different materials. She arranged the sheet as follows. Okay, in this case, so they tell you got setup A and setup B. They are rearranged very differently. Okay, so in this case, PQRS, SQ, PR. So in a way, they are kind of reverse. Okay, they are that kind of reverse. Okay, so she measured the distance traveled by the light for each setup, and the result are shown in the graph below. So let's take a look at A first. So for this kind of question, right, you know that A travel 15, right? That means the light actually hit here, then did not move at all. So over here, right, that means this one opaque, block light. That's why the light cannot go to S, cannot reach to 20. Okay, block light. Okay, for this part. So this part is opaque. So we already know that R is opaque, right? So I'll put it here. R is opaque. So this is opaque. Based on the first result, we know that R is opaque. Then for setup B, right, the amount of light travel in this way. Okay, it travel all the way until it hit R, then at 20, then it stop. Okay, for this part, okay, the result is at 20. So what does it mean? It means that for the first two setup, right, the light can pass through these two parts. Okay, that means P and Q is definitely transparent. Okay, P and Q is definitely transparent. Then what about S? Because S over here, right, it was not tested in setup A, but it was tested in setup B, right? Do you realize that the light can also pass through? So what does it mean? It just means that S, Q, and P, they are all transparent, or in a way they allow light to pass through. Okay, but for R, it blocks light. That's why the light was measured until a certain distance, and that distance is where R is. Okay, this is opaque. Okay, in this case. So which of the following statement is correct? Okay, so number one, Q sheet allow light to pass through. Yes, this is correct. We have already established this. This is correct. Q allow light to pass through. So number one is the correct answer. So let's take a look at 2, 3, 4. Okay, so sheet S does not allow light to pass through. This is wrong. Okay, because we already say that S allow light to pass through. Okay, which is over here. Okay, so 2 is wrong. P and Q do not allow light to pass through. Q do not allow light to pass through. That is correct. But P no. P allow light to pass through. Okay, so 3 is out. Okay, in this case. So 4. Sheet R allow more light to pass through than Q. So this is actually wrong because why? We already established that R blocks light. Okay, while Q allow light to pass through. So it should not be R allowed more light. In fact, it should be R allowed less light to pass through. So in this case, number 4 is wrong. So the only correct answer should be number 1. Okay, question number 28. Hui Min wanted to find out how styrofoam will affect the temperature change of cold water. So she placed equal amount of cold water into two similar beakers of A and B, covers both sides of beaker B with styrofoam. Both beakers were placed in the classroom. So in the typical classroom, right, the room temperature will be around 25 degrees Celsius. Okay, we're taking that with reference. So the temperature of the cold water will be at 10 degrees. How do I know? Okay, because all the graphs they start at 10 degrees Celsius. 10 degrees Celsius. So in this case, right, where will be the heat going? Heat will always travel from a higher temperature to lower temperature. So the heat will travel from the surrounding into the water. Okay, so in this case, right, so let me just draw arrow to indicate, okay, the heat transfer from the surrounding into the cold water. So can you see that I draw 4 arrows to show that the temperature, the heat from the surrounding is traveling much faster into beaker B. Okay, as for beaker B, I'm going to draw 2 arrows only to symbolize that the amount of heat from the surrounding traveling into the cold water, right, is much lower because of that layer of styrofoam beside it. That's why I only draw 2 arrows. So in this case, right, the concept is really about this. Okay, the styrofoam, okay, in this case, right, being a poor conductor of heat, right, okay, for this part, poor conductor of heat, and will therefore slow down the rate of heat gain by the water from the surrounding. So the water is actually gaining heat from the surrounding, but it's being slowed down by the layer of styrofoam beside it for beaker B. Okay, so what will happen is that the result, right, is that the temperature of the water in beaker B, right, will increase more slowly or much slower, okay, and reach temperature more slowly. That means they will reach a room temperature, okay, but more slower. So maybe over here, this may reach room temperature in about 10 minutes. Maybe about 10 minutes. Okay, then this will reach room temperature maybe about 15 minutes. It takes a longer time to reach room temperature. So if you take a look at the following 4 of the graph, right, which one is most likely to be answer? Okay, or which one is least likely first? Okay, 1 and 3 straight away out, because over here we say that if you give it long enough time, both of them will reach to room temperature. But do you see that they did not reach to room temperature yet at that point of time? And for beaker A, right, it seems that it's rising, okay, to a temperature that is very, very close to 80 degrees, okay, in this case. And this is illogical. Okay, this is illogical. Can you see? the temperature is quite close to 80 degrees. It is quite illogical because the temperature of the classroom cannot be at this temperature. So 1 and 3 straight away out. Okay, so we ended up with 2 and 4. So which this part of the arrow here, right, it actually represent more like a room temperature in this case. Okay, but between 2 and 4, which one should be the correct answer? Let's take a look at this. So for A, right, okay, the one without styrofoam, no styrofoam. This one with styrofoam. Can you see that the temperature increase, right? It takes, for B, right, this is the time taken for it to reach the room temperature. Okay, time taken for it to reach the room temperature. For A, right, this is the time taken for it to reach the room temperature. Can you see it takes a, for A, right, it takes a shorter time based on the length of the arrow that I draw. Okay, for B, it takes a longer time based on the blue color width that I draw over here. Okay, for this part. Okay, so in this case, 2 must be the correct answer because we already established that the styrofoam will slow down heat gain by the water from the surrounding, so it will take a longer time to reach the room temperature. So in this case, the graph 2 really reflects what is being shown in this situation over here. Okay, that's why 2 should be the correct answer instead of 4. Okay, 4 is just the reverse, but it's trying to say that B actually reached the room temperature much faster than A, which does not reflect what is being shown, okay, in the what is being reflected in the experiment. Okay, that's why we will not choose 4. Okay, in this case we will choose number 2. Okay, now we are moving on to the open-ended section. So for this part, the open-ended section is really 44 marks. So, but in this case, right, it will be revised to 40 marks for this year's students that is taking their end-of-year exam. Okay, where the section A will change to 60 marks. So it will be made to a 60-40 format. So question number 29. Okay, in this case, we have a diagram to show that a boy is feeding a duck. Okay, so over here, these are probably the food for the duck. Okay, food for the duck in this part. So the duckling need food, water, and what to stay alive. So over here, this actually is taken up from your textbook. Okay, so it's really telling you that what should be the blank. So you have water, you have food, so the blank should be air. Okay, air. All living things need air, food, and water to survive. Without air, food, and water, without any of those, living things cannot survive, they will die. Okay, for B, okay, the duckling moved towards the food when the boy put the food on the table. This is trying to show you what? Is it trying to show you grow? Is it trying to show you respond to changes? Is it trying to show you reproduce? The answer is respond to changes. Okay, when there's food, the duckling moves towards it to get that food, okay, that it needs to survive. So respond to changes. Okay, question number 30. So we have a lamp, which in this case is a light source. So it will hit an object and into the person's eye. So basically, this diagram shows you how a person is able to see an object. So then fill in the blanks with the correct word. So the lamp is actually your light source. The lamp is actually your light source over here. So in this word, in this case, this one you can cancel out. So light is reflected. This is an action of reflection. Okay, reflected into her eyes. That's why she can see the object. So in short, normally, this is actually one way that you can use to be able to say how a person see an object. Light source, object, reflected into the person's eyes. Okay, so in this case, right, these are one of the writing format that you can use, okay, to describe how a person see an object. So next up, 31. Put a tick in a box if each of the following has mass or volume. Okay, so basically mass is the amount of matter in the object. Volume is really how much space the object occupies. So honey, as I put it over here, this is a liquid, so it will has mass and has volume. Okay, so for ball, right, solid, it will has mass, has volume. Light is a form of energy. Okay, as long as you can classify anything under energy, right, it will be non-metal. Okay, some other example of over here, right, will be a sound as well as heat. Okay, all these are energy, non-metal, so has no mass, has no volume. Okay, for this part. Okay, so let's go to 32 very quickly. So you are given 4 objects: the fern, the bread mold, mushroom, coconut. Then you are asked to be classified fungi or plant. Fern definitely is a plant. Fern is a plant. Okay, bread mold is a fungi, definitely, because it cannot make its own food, just like a mushroom is a fungi. Your coconut tree definitely is a plant. So if you put these words into the correct boxes, you should have something like this. Bread and mold, plants will be fern and coconut tree. Question number 33. So Kira stroked two similar iron rod X and Y with the same magnet as shown in the figure below. So this one stroke 10 times, one stroke 40 times. So both rods become magnet and were used to attract similar pins. Circle the correct answer below. So X over here, which is the one that stroked less, only 10 times, it will attract fewer, the same, or more than Y. So in this case, Y, rod X stroke 10 times lesser than Y, it must have attracted fewer pins. Okay, the lesser number of stroke, the weaker the magnetic strength of the magnet. Okay, so in this case, should be the correct answer. Okay, fewer pins. Okay, let's move on to 34. Okay, 34 onwards, right? Over here, this is actually your actual open-ended question. Actual open-ended question, really. Okay, for this part. Okay, this is really the part that you really need to start to write longer sentences to be able to get the full mark. So over here, Jun Xiang set up an experiment using identical plant as shown below. So you got setup A, setup B. Okay, both the plant, they are the same. Okay, they have water, they have a seal rubber stopper. Okay, but one thing different is that A, right, the roots is wrapped inside plastic bag. For B, right, the root is exposed to water. Then they ask you, what will happen to the plants in each of the cells after 4 days? So after 4 days, right, what will happen to the plant, not the water level? Okay, what will happen to the plant but not water level? So you have to talk about the plant. So plant A, right, if the roots is being wrapped with the plastic bag, is no longer in contact with water. Okay, no longer in contact with water, no longer in contact with water. Okay, no longer contact with water, so it cannot absorb water, cannot absorb mineral salts. So what will happen to the plant? Without water, without mineral salts, the plant will not do that well. Okay, the leaf will start to dry up, will become withered. Okay, so over here the leaf will wither, or you can see the plant will die. Both are fine. Both are fine. Both are correct observation. So for B, then it will continue to do well because it can absorb water to continue to survive. So you can say leaf will remain healthy or alive. You can talk about the leaf, or you can say the plants will survive. Both are fine. Okay, then you explain your observation in A. So your focus, you need to know that your focus is A. Talk more about A. Okay, don't need to talk about B. Okay, talk more about A. Okay, so for this part, the observation is that in A, what happened? The roots are not in contact with water, so they are not touching the water. Okay, so what happened? Cannot absorb water and mineral salts. So this is related to the function of the roots. So if you cannot absorb water and mineral salts, what will happen? Without water, the leaf cannot carry out photosynthesis or make food for the plant, and the plant will eventually die. So just notice the words in the bracket are optional. That means you don't really need to write this word as of now. You don't really need to write this part. Okay, but for this question, you don't really need to. Okay, so you can just say without water, the leaf cannot make food, okay, for the plant, and the plant will eventually die. Good enough for this part. Okay, or you can say the leaf will eventually wither. Okay, both are fine as well. Okay, so in this part, just to recap, for part A, right, if you write your answer as water level for A, remain the same. Water level remain the same, and water level will decrease. Water level will decrease. These are observation, but this observation is not about the plant. Okay, this observation is really about the water. They are not asking you about the observation of water, so you cannot write this. This one will not be accepted. Okay, do not accept for this part, because they are eventually talking about the plant itself. So you have to talk about this. Okay, for this question. Okay, let's move on to question number 35. So 35 is really about body systems. So Steve is able to pull his body upwards as shown in the diagram below. So he pull himself upwards. Okay, so which two systems in Steve's body work together to enable him to perform the movement of pulling himself up? Describe the function of these two systems. So the two systems, will be number one, muscular system. Okay, and the function of this is to help your body to move. Okay, the second one will be your skeletal system. Okay, so it gives the body shape. It is the main function. It also protect the important parts of your body for this system. Okay, so in this case, right, this will help you to be able to answer this question. But if you were to be asked, okay, this kind of additional question, okay, describe how the muscular system works with the skeletal system to help Steve to pull himself up. Okay, let's say this is a descriptive question. Okay, then you have to combine these two answers, how they work together. Okay, so you can talk about this in this manner. This is how I would have approached the question. So the muscles are attached to the bone. Okay, so they are attached to the bone. So when the muscle contract or the muscles pull, try to relax itself, right? They pull onto the bone to cause movement. They pull onto the bone, therefore movement can happen. Therefore, this person can move himself up in this case. So this is one way to actually describe this. If let's say they did not give you the box, okay, because over here the box, right, is really they're asking you for this two. Okay, these two systems work together to help him to move up. But how he move up is because the muscle will pull onto the bone. Okay, but this part, right, is just asking you a basic function, okay, of the systems that you are referring to. So muscles help the body to move, skeletal system protect the body, give the body shape. These are the few ideas that will be good enough. So after the workout, okay, Steve gulped some water and choked on the water. Okay, he choked. Okay, he was fine after he coughed. So what happened is that he's trying to remove water when he cough, right? He cough. He's trying to cough out, right? So which part of the body has the water most likely travel to? Okay, that means the water in this case, right? It is not going to the right place. Not going to the right place. It means most of the time the water, most of the time, right, if this is correct, right, the water should have gone through the gullet, through the mouth to the gullet, then to the stomach, right? Okay, then since it did not went to the gullet, then where did it went? Most likely it went into the windpipe. Okay, it went to the windpipe, into the lungs. Therefore, it must have choke it out, so that, or cough it up to actually remove the excess water, so that the lungs can still breathe in air. Because imagine your lungs is filled with water, then you cannot breathe in air anymore. Then you might need to go to the hospital. For this part, question number 36. Chiral glue 5 iron nail label ABCD to a bar magnet as shown in the diagram below. So you have the magnet. Okay, you have the magnet over here, then you have the iron nail that is attracted toward it, and you have a tray of iron powder, and you notice that iron is being used over here. You need to know that it is a magnetic material. Okay, this part is pretty important. Okay, the magnet and nail were lowered into the tray filled with the iron powder. Then Cairo observed that there was some iron powder on the iron nail when he leave the magnet above the tray. Okay, on the diagram, circle the iron nail which attract the most amount of paperclip. The most important part of this question is most. Okay, most. Which one will attract the most? So in this case, right, if you lower it, right, you will notice that this one will attract the most. This one will attract the most. Let me just draw it. Okay, this one will still attract, maybe less. This one maybe even lesser. Okay, maybe this. Okay, this one will attract. Okay, then this one will attract. Just like your A. Because why? These two are located at the poles. The poles over here will be the strongest part of the magnet. Okay, since it's the strongest part of the magnet, it has the highest amount of magnetic strength. It will be able to attract the most paperclip. So the answer that you should be circling, right, should be A and E. Okay, those circle are the things. Okay, there should be two of them. You should circle A and E. So how to give you the reason? This is what you can say. You can say A and E. Okay, A and E are the poles, or iron A and E are located at the poles of the magnet, so which is the strongest part and will attract the most paperclip. So the main idea is that poles, strongest, attract the most. This will be the core idea of this question for part A. Okay, so in another setup, okay, Cairo glue 5 iron nail onto the wooden bar. Okay, so this wooden bar is not a magnet. Not a magnet. Then they ask you, predict, that means tell me what you will see. Predict is tell me what you will see. Is another way of rephrasing an observation question. What Cairo will observe when he lowered the iron bar and nail into the tray filled with iron powder. So what will happen is that this wooden bar, right, since it is not a magnet, right, these things, right, will not be, the magnetism will not be able to influence the iron nail in any way because it's not a magnet to begin with. So nothing is going to be attracted. to the base of the iron nail. Nothing is going to be attracted. So the wooden bar is not a magnet and cannot attract the magnetic material, which is the iron powder over here. So what we observe is that no iron powder will be attracted, or no iron powder found on the nail. Okay, nothing will be attracted, nothing found on the nail. This is the main idea over here. Okay, and why, right? Okay, why in this case, right, is not needed, because over here it did not ask you to explain. Did not ask to explain. Did not ask to explain. So you don't need to say why, but I'm just putting a written explanation so that you know why did it happen, why the answer is no or nothing is being attracted. Okay, because wood is a non-magnetic material and cannot be made into a magnet, or it itself is not a magnet and it will not attract any iron powder. Okay, question number 37. Billy wanted to find out what temperatures rainwater and seawater boil. So you can see there's two types of water, seawater, rainwater. So immediately we know that this is more or less the change variable. Okay, and how do I phrase it? I can say type of water. The change variable here is the type of water. So he set out an experiment. Two of the container of similar capacity were used. And over here, you can see this entire setup. We got the thermometer, you got the metal container, glass container, you got the rainwater, you got the seawater, and they already tell you this is the amount of rainwater and seawater that is being used, okay, in this setup. Okay, Billy friends Max told him that this experiment is not fair. That means over here there is more than one change variable. There's more than one change variable. That means, right, by right you should have changed this, but you change something else that will also affect the time taken for it to boil. And this is something that it should not have been done, because it will affect your reading, it will affect your result, or it will affect your conclusion. Then at the end you can't tell whether rainwater or seawater, which one boil faster or which one boil slower. Okay, because of more than one factor is being changed in this experiment. Then they ask you, suggest two changes plural, okay, Billy should make to the setup so that his experiment can be a fair one. So first up, you can talk about this. Okay, or you can even talk about this. Okay, so in this case, right, you notice that the container, they are made of different material, right? So what should you do? Change the material of the container. Okay, so there's many ways to answer this, many ways. Okay, so you can say keep the material of the container to be the same for both setup, or you can even say use metal container for both setup. That means both use metal, or even that you can say both use glass. Okay, good enough for this part. Okay, then for second part is really this part, the second part. You have to talk about this. Okay, because over here, the greater the amount of water being used in this setup, the longer the time it takes to boil. So in this case, right, you don't want the amount of water to affect the time taken for it to boil, because you want the time taken for it to boil to only be affected by the type of water that is being used in this experiment. Therefore, the amount of water, right, they should be the same. They must be the same. Okay, so keep the volume of water used to be the same. Okay, okay, in this part. So this should be the correct way of answering this question. So what cannot be accepted? So if you write something like this, if you just write this, okay, material of container, full stop, then you don't tell me whether you want to change it or you want to keep it the same. Okay, then I don't know what I should do. Okay, you are just leaving your answer as a variable. You're just telling me or the material of the container is a variable. But what should we do with this variable? Should it be changed or should it be kept the same? Okay, we don't know in this question what you're referring to. So basically, if you leave your answer as the material of the container, it's just not clear. Okay, another one will be the amount of rainwater and seawater. It's just not clear. Okay, what do you mean by amount? Do we want to change or do we want to keep them the same? Okay, so that's why this one do not accept. Okay, if you just write material of container without elaborating whether you want them to be the same or to be different. So this part must be written. The word same must be written. So let me write this part out. The word same must be written. Okay, so in this case it must be mentioned, and so that you are trying to say that the variable should be kept constant or kept the same, so that it will not affect the result, which in this case is the time taken for the water to boil. Okay, so part B, the diagram shows a thermometer that is being used in a science experiment. When the bulb of the thermometer is being placed in the hot water, the liquid level in the stems rises, showing an increase in the reading. Okay, so basically the liquid went up. The liquid went up in this direction. Okay, so explain how the liquid in the thermometer rise when the bulb, okay, of the thermometer is placed in the hot water. So can you see actually this question, right, is a little bit tricky because you need to know what words to actually fill in the to put into the blanks. So in this case, right, if you read it logically, heat flow from a higher temperature to a lower temperature, right, or hotter place to colder place. So heat always flow from higher temperature to lower temperature, or hotter to colder or cooler place, right? Hotter or cooler place, right? So in this case, you have to identify where is the hotter place, because from, okay, so the hotter place will be the hot water. So this part must be hot water. So heat flow from hot water to where? So if you were to put the hot water over here, this is the hot water. It will flow to where first? It will flow to the bulb. Okay? It will flow to the bulb. Okay? When it flow to the bulb, then the heat will travel to the liquid and causes the liquid to rise, and it reflects the correct temperature of the water that you're measuring. So in this part, right, this one should be your bulb. And use the words that is labeled in the diagram and to the liquid, okay, which is this part. Okay, so then it will show you the change in temperature. Okay, the heat gain or loss by the liquid cause it to expand or contract. Therefore, the liquid in the stem rises. So this part, right, when the liquid in the stem rises, right, it's trying to show you that the volume increase. So the volume increase must be related to expansion. And expand, right, what do you need to expand? You need to gain heat, or the substance need to gain heat for the expand. So it should be heat gained by the liquid cause it to expand. Therefore, the liquid in the stem, right? So for this part, it should be gain heat, expand. Okay, for this portion. So question number 38. Okay, Nisha pour 85 ml of water from a conical flask into the measuring cylinder. Then on the diagram below, draw the water level that Nisha would have observed in the measuring cylinder below. So over here, you notice that it's being placed straight. Okay, over here is being placed straight. So the water level that is found on the measuring cylinder, right, should be straight. Okay, horizontal line as well. Okay, we assume that it's being placed on the table. So for this part, right, you notice that the scale, okay, the scale over here, this is 100 ml. Okay, 100 ml. So we need to locate where 85 is. Okay, where 85 is. So you're reading it up. So 85 should be somewhere around here. Okay, so it's 81, 82, 83, 84, 85. So it should be you should draw a straight line across here. Use a ruler. Okay, so this should be 85 ml. Okay, so with that will answer this question. Okay, for this part. Okay, okay, state two properties of water. Two properties okay, that allow Nisha to pour water into the measuring cylinder to measure the volume of water. Okay, allow Nisha to pour the water into the measuring cylinder and measure the volume. So the first part, to pour the water into the measuring cylinder, right, it must have no definite shape. That's why it takes the shape of a container. There is no air spaces. Okay, then the next part, to measure the volume of water. Okay, in this case, right, it must be having a definite volume. So that means whatever water that you pour into it, right, it will accurately reflect the true volume of the water, because the volume itself is fixed. It will not change depending on the container that you place in. It will not change depending on the container you place in. So that means what I'm trying to say, that if you pour 85, it will be 85. If you pour 10, it will be 10. Okay, in this case, because the volume is fixed. Okay, it will not change itself depending on the container that you are placing it in. Okay, so the two properties in this case is no definite shape, and having a definite volume. These are the properties of any matter that exists in a liquid state. Okay, water exists in a liquid state at room temperature, and this is what we are talking about. Okay, so how do you answer this? Okay, water is a liquid, and liquid has no definite shape, has a definite volume. This is the two key ideas. Okay, now we go into a little bit more in depth about this. Okay, why can the volume of water be measured directly by reading the scale on the measuring cylinder. Okay, why can you do so? Okay, so this is the first question. Okay, that means when you read off 85, right, why 85 represent the full volume of water? Okay, in this case, right, I will use the idea of no definite shape. So over here, this part, right, because it has no definite shape, it completely takes the shape of the measuring cylinder. Therefore, right, you will not have expect what? No air gaps. Okay, there's no air gaps in the measuring cylinder or between between the water. So 85 represent full volume of water. Okay, but you cannot do it for pebbles, which is a solid material. So if you do it for pebbles, right, in this case, right, you cannot, even if this part is 85, you cannot say that the volume of pebbles is 85 because over here there is air. And how come the air will be there? Because the shape of the pebbles is fixed. It will not change itself to match the measuring cylinder, unlike a liquid, okay, which do not have a definite shape. Okay, so this is the main idea of how to answer this particular questions, when they arise. Okay, no definite shape for this question. Okay, then for the second portion, right, what kind of question that is more suited for definite volume? So we can talk about this. Why can the volume of water be measured using a measuring cylinder but not air? Why the measuring cylinder can measure volume of liquid, okay, but we cannot measure air, which is a gas. Okay, the main idea is this. Okay, liquid has a definite volume, so the amount of space it occupies remain constant no matter what kind of container you place in. Today you can place in a measuring cylinder, you can place in a beaker. So whatever you read off to the scale, right, it is the true volume of the water. Okay, but unlike a gas, okay, the gas has no definite volume. Okay, it will expand itself to fill out the remaining space that it is. Okay, if you put a certain volume of air or quantity of air into 100 centimeter cube of measuring cylinder, it will just fill up the entire 100 centimeter cube of space, okay, regardless of the actual volume. Okay, therefore reading the scales will give you the volume of the container, not the volume of gas. So what I'm trying to say is that, right, if let's say this is a 100 centimeter cube centimeter cube or 100 ml of measuring cylinder, right, you take a syringe, right, you take a syringe, this syringe maybe 2 ml. Okay, you compress the air in, right, so the volume of air will just take it as 100. Okay, because the 2 ml of air, right, that you place it in, right, 2 ml of air that you place it in, it will just expand to fill up the remaining volume of the or remaining space of the measuring cylinder. So whatever you read off will be something like this. Okay, this will be the volume of air that we are talking about, which is what I draw in the blue color. Okay, therefore this is the meaning of no definite volume. It can be 2, it can be 100, depending on the container that it is being placed in. Okay, the volume is not fixed. Okay, so in short, the volume of gas changes depending on the container that is being used to contain it. Okay, we cannot accurately measure the volume of gas directly. Instead, we assume that the volume of gas is equal to the volume of container that is being placed in. Okay, so if the volume of container is 100, the volume of gases inside is 100. If it's 200, then it's 200. So we just assume it because this is the property of having no definite volume for this part. Okay, let's move on to question number 39. Newton set up an experiment as shown below. So you got a torch, okay, then you got position A, B, and C, and you notice that position A, okay, maybe position A is nearer to light source and nearest to the light source, while C is the furthest away from the light source. Okay, so these are the probably the key information I'll take note before I do this question. And you got a clear glass block in the middle. Okay, so in this case, the clear glass block may block some light only. Okay, so in this case, right, Nathan placed a clear glass block at position A, B, and C. At each position, he measured the length of the shadow cast on the screen. So he's trying to tell you, right? So he placed this. There's some shadow casting on the screen. There's some shadow casting on the screen over here. Okay, some shadow. It's being this is the story that's being told to us. Okay, so Nathan has difficulty measuring the length of the shadow above as the shadow cast on the screen were unclear, not dark enough. So there's some shadow, but they are just unclear, very faint, not dark enough. So what are the two changes Okay, he should make in this experiment so that the shadow is clear, dark enough. That means I want to see the shadow darker. I want to see the shadow darker. So instead of this is the shadow, I want the shadow to be something like this. Very dark, very dark. Okay, or in fact, let me just exaggerate this part. So I want the shadow to be like this, very dark. Okay, so in this case, right, you think about it. If I want the shadow to be very dark, darker shadow, so I must choose a material that can block more light. So the area of darkness or the area where there is no light can be darker. Okay, you must choose a material that block more light. So you must choose something that block more light than the glass block. Then you should be able to have a darker shadow. So what will be the first option that you can go with? Okay, you can say change to translucent. Okay, because over here this part we'll just take it as this is closer to transparent. Okay, it's closer to a transparent block. You can say change your translucent block. Okay, then you will have a darker shadow as compared to the clear glass block. Or you can even say change to opaque. Okay, opaque is the best because the shadow will be the darkest among the three different materials, okay, that has been proposed here. Okay, so it will be the darker shadow. So this actually answer 2 will be a better answer, okay, for this part. Change the block to an opaque block, okay, to an opaque block. Okay, why? Okay, block more light, cast a darker shadow. Then he will be able to measure it very clearly. Okay, another problem with this experiment is that it could be that there is some light source over here. There's some torch light. Okay, then it shine light over here, right? So when it shine light over here, what will happen? The shadow will become way faint. Okay, so what will happen is that maybe the shadow over here become more faint. Okay, or become much more smaller. So it's difficult for him to measure. So what should he do? Okay, he should remove this light, make the room darker, or ensure that the torch is only the source of light. So you can say something like this: conduct the experiment in a dark room, or ensure that the torch is only the source of light. There is no surrounding light that will affect the darkness of the shadow. So these are the possible ways that you can actually do it. But of course, the easiest answer is actually this. Okay, for this part, okay, the easiest answer will be carry out the experiment in a dark room. Okay, or so that there's no surrounding light that will affect the darkness of the shadow. Okay, Nathan carried out an experiment properly and made the necessary changes to his experiment using the following numbers viewing the length of the shadow at A and C. Okay, in the table below, A versus C. So the length of shadow at B has been given. Okay, so it's 10. So if this is 10, if it's 10 cm, right, they're asking you A and C what will be the length of the shadow. Okay, as you know, the nearer the object, it blocks more light, the shadow will be larger. So this part over here, nearer the object to the light source, it will block more light, larger shadow. So it will be larger than 10, more than 10 cm. Then of course, the further the shadow block less light, it will be less than 10 cm. Okay, so this will be the key ideas that you will be using. So now we go back to this. Okay, A will be more than 10, C will be less than 10. So over here, the only number that is more than 10 is 15. Okay, the only number that is less than 10 will be in this case 5. Okay, so for this, right, why the shadow, right, for C, right, cannot be 0 even though 0 is less than 10, right? It's because if you are telling me the shadow is the length of the shadow is 0, basically is no shadow. No shadow. And it does not make sense, right? If you place an object over here, it will definitely block some light. There will be some shadow over here, and this is this is at a position that is somewhere between the torch and the screen. There will be some shadow. So the shadow cannot be 0 cm. So in this case, 0 cm is out. 0 cm is out. So in this case, the best answer is 5 and 15. Okay, for this part. Apart from changing and moving, that means you cannot say you want to change. You cannot say you want to change or you want to move the glass block. You cannot say you want to change or move the glass block. Say another way to increase the size of the shadow that's cast on the screen. Okay, so what can you do? Okay, to increase the size of the shadow. Okay, there's two ways that you can do it. It's either number one, you move the object nearer the light source, you block more light, right? So that will be the first part. Okay, that will be the first part. Or you move the screen further away from the object. If you move the screen further away from the object, the shadow will become larger. Okay, for this part, let me just show it to you. Okay, so this part, this is a torchlight, this is the block, this is screen at position 1. Position 1. And this is the shadow. This is the shadow that is being cast over here. This shadow being cast, right? So if I were to move to position 2, move the screen further away from the object, right? Over here, so the shadow that is cast, right, will be much longer. Okay. Okay. So this is some ways that in exam you can use to actually help you. So let me just put it down here. Position 2, okay, which is this part over here. Position 1 is this part. Okay. Okay, so you can see this is the length of the shadow for position 1, and this is the length of the shadow for position 2. You can see the green color arrow is much longer than the black color arrow. So when you move the screen further away from the object, definitely the size of the shadow will increase. Okay, this is one way to actually kind of do it. Okay, do not accept. That means if you write this answer, you're going to get 0. So what are the answers over here? We talk about the glass block. Okay, you move the object nearer the light source. It's the same as this, but you cannot say the one in red, right? Because you are moving the glass block. I want you to move the torchlight, not the glass block. Okay, or you move the screen. Okay, or another one, you move the object further away from the screen. Okay, it's the same as this. Okay, move the screen further away from the object, or move the object further away from the screen. Is the same idea, but you just cannot write this because the question say you cannot change the position of the glass blocks, so you cannot write this. Okay, question number 40. Andy carried out experiment as shown below. So you have a glass flask, and inside the glass flask you probably have air inside. There's a heat source. So and after a while the bubbles start to come out from the glass tube. Okay, and it's being placed. The glass tube is being placed in the container filled with water. So Sandy noticed that the glass become hot after a while. She observed bubbles. Okay, shortly after. Name the substance that is found in both the glass and in the bubbles. Okay, what is found in both glass and the bubbles, right? The substance over here will be your air. Okay, in this part. Okay, this one pretty clear cut. Okay, so explain clearly why the bubbles were observed. So initially when she put the glass flask, right, into the container of water, initially there is no bubbles. I believe so. You will know there's no bubbles. So only after he put the heat source, right, then the bubbles started to appear. Okay, and these bubbles, you know that it's made out of air, right? So in this case, what happened? The air actually increased in volume. What causes it to increase in volume? Okay, so this part, the volume actually increased. Okay, the volume in this case, right, is greater than what the glass flask can contain. That's why it escaped out of the glass tube as a form of air bubbles into the surrounding. Okay, so the volume increased. So volume increase, it means that the air inside must have expanded. Okay, so how come it will have expanded? Probably it have gained heat from the flame, because the bubbles only started to appear when you put the flame beside it. Okay? And they tell you that the flask become hot. So in this case, it must tell you that somehow the air inside the flask must have gained heat from the flame. So how do you explain this part? Okay? This part is really about gain heat expansion. Okay, so you probably need, the first part you need to write is that the air in the flask gain heat. Okay? This part is quite important. Not the flask that gain heat, it's the air inside that gain heat. Okay? And you cannot just write air only. Okay? Because air, are you referring to surrounding air, or are you referring to the air inside the flask? If you are referring to the air inside the flask, that must be stated, or that must be brought out. So this part is pretty important. Okay? Must be written. Air inside the flask. Okay? If not, someone might have interpreted it as the surrounding air if you just leave it as air alone. Okay? Air gain heat from the flame and expanded, move out of the glass tube as air bubbles. Good enough for this part. So the main idea is that gain heat from where? Okay, from the flame and expanded. Okay, therefore it moves out of the tube as air bubbles. Okay, so this part is how you answer for B. Then for C, right, Sandy made some changes to her setup. He found that the bubbles appear much quicker. Okay, so over here they are trying to tell you that the expansion process, right? The expansion is much faster. Okay, so if the expansion happen much faster, the air inside must have gained heat faster. Okay, let's take a look at what happened or what did she do to make sure that the air inside gain heat faster. So fill in the table below to explain why each of her action allowed the bubbles to appear more quicker. The volume increase much faster. Okay, add one more lead candle. So add one more lead candle, that means, right, you have what? You have more heat source. Okay, more heat source over here. Let me write it, draw in red. Okay, or let me draw in red. Okay, you have more heat source, so the air inside can gain more heat or gain heat faster, expand faster, appear out of the glass tube as bubbles much faster. So this is actually how you can explain this part. So since there's greater heat source or there's more heat source, both are fine. Okay, greater heat source or more heat source. Okay. Okay, the air inside the flask will gain heat faster, expand faster. Okay, gain heat, expand faster. Okay, for this part. So change the glass to metal one. So as you know, glass versus metal, metal is a good conductor of heat or better conductor of heat. So you can compare. You can say better conductor of heat than glass, or you can just say good conductor of heat. Okay, both are fine. Both are fine. Okay, for this part. Okay, so the first reason or the second reason, you can use any of this, both are fine. So I'm trying to state the reason based on two different ways of answering. Okay, so you can say that the metal flask will speed up the rate of heat gain by the air inside the flask, okay, from the flame. Okay, by the air inside the flask from the flame. Okay, this is one part, speed up heat gain or speed up the rate of heat gain. Okay, so the second part, you can talk about the air in the flask will gain heat faster from the flame through the metal flask. Okay, both are fine. Okay, both are fine. For this part, gain heat faster from the flame through the metal flask, or you can say speed up the rate of heat gain. Okay, so both are trying to say the same thing, but it's just different phrasing, different wordings. Okay, so for question number 41, this is on magnet. Okay, in the diagram below, a cup was attached to the disc using a few strings. When the battery was placed, the disc was attracted to the magnet, and weights of the same height were placed in the cup until the disc fell. Okay, the result will recorded in the table below. So they have 20 coins, 2 weights, then it will drop off. Okay, 30, 5 weight drop off, 48, 50, 10. Okay, so they are trying to tell you one thing over here. When you increase the number of coin, right, what happened? Okay, the magnet become, or the electromagnet become stronger. Okay, then when it becomes stronger, right, you actually need more weights to actually to separate the attraction between the disc and the electromagnet in this part. Okay, so in this part, right, what happened is that the number of weights added before the disc fell off, right, is an indication of the magnetic strength of the electromagnet. If the magnetic strength of the electromagnet is stronger, you will need more weights to separate them. If it's weaker, you need less weight to separate them. Okay, this is the main idea of the question. So from the result in the table above, state the relationship. Okay, read this very carefully. State the relationship between the numbers of coil, number of turns of wire around the iron rod, okay, or around the rod, and the magnetic strength of the electromagnet. So notice this, this is asking you the magnetic strength of the electromagnet. They are not asking you the number of weights added before the disc fell. So you are supposed to interpret this. You are supposed to interpret this as this. So you are supposed to know that if you need more weights, it means the magnetic strength of the electromagnet is stronger. So when you're writing this part, right, don't write this. Use this instead. Use this. Use this phrasing. Okay, don't use the number of weights. Okay, because the question is asking you the magnetic strength of the electromagnet. You are supposed to use the number of weights to tell the magnetic strength. More weights needed to separate the attraction, right, means stronger. Less weights needed to separate the attraction means it is weaker. So how do we state the relationship? As the number of coil increases, if you need more weight, it means that the magnetic strength of the electromagnet is stronger, it actually increases with the number of coils added. So for the first part is that you can talk about this as the number of turns of wire around the rod increases, the magnetic strength of the electromagnet increases. Okay, so this is one way of answering, or you can say this this way as well. Okay, the greater the number of turns of wire around the rods, okay, the greater the magnetic strength of the electromagnet. Both are fine. So do you realize that the only words that you need to add in, or the only words that you need to analyze, is this part: greater, or increase. Okay, this increase actually comes from this part over here, because more weight needed to separate attraction between the disc and the rod, right, means the stronger it is. So this number actually represents the strength of the electromagnet. Okay, so if you write this, it will not be accepted. If you write this, it will not be accepted. If you write something like this: as the number of turns around the rod increases, the number of weights added before the disc fell off increases. If you just copy it wholesale over here, you will not be given any marks. You'll be marked down 0, because the question states very clearly the magnetic strength of the electromagnet. So you cannot tell me about the number of weights fell off, the number of weights added before the disc fell off. You just cannot use this. You have to reinterpret this as the strength of the electromagnet. Okay, so I hope I make myself clear for this part. This is important because it's a very easy question, but also very easy to get it wrong. Okay, so let me just add a sticker over here. Important for this part. Okay, this is important. Okay, for this. Okay, other than the methods mentioned above, suggest another way, right, so that the disc will still remain attracted to the rod after 10 weights are added. So they are trying to tell you, right, okay, I want the disc and the rod to remain attracted, okay, after 10 weights added. So I want a stronger electromagnet. I want a stronger one. I want a stronger electromagnet. But you cannot tell me increased number of coil, because this is the method that's being mentioned in the question or in part A. You cannot tell me this. Cannot tell. Okay, so what are some other methods, okay, that you can use to increase the strength of the electromagnet without saying increase the number of coils? So you take a look at this. Okay, so what you can do, increase the number of battery. Okay, when you add one more battery over here, there's more electricity flowing through the coils of wire around the iron rod. It makes it into a stronger electromagnet. So then you will need more weights to separate the attraction between the disc and the rods. So in this case, add more batteries, okay, which is to fulfill this part, making a stronger electromagnet. Okay, suggest a material that can be used to make the disc and the rod. Okay, what are some materials that you can choose to make the disc and the rod? So you go back to this. Okay, so what is one materials that you can choose over here? It must be a magnetic material. It must be a magnetic material, so that the rod can be made into a electromagnet and attract the disc. Okay, so that the rod can be made into an electromagnet and attract the disc. So what about the disc? The disc also must be made of a magnetic material, so that it can be attracted by the electromagnet and able to carry out the experiment where we test how many weights you need to separate it from the to separate the disc from the electromagnet in this case. So for this part, right, both are magnetic material. So what is the specific example of a magnetic material? So these are the 4: iron, steel, nickel, and cobalt. The other one will be iron, steel, nickel, and cobalt. Just choose any of these 4. So when the battery is removed, the disc will drop instantly. Okay, explain why replacing the disc with a button magnet will prevent the setup from working properly. So this setup is really to test the strength of the electromagnet. Okay, so now let us look at the one in red color and try to address this part. Okay, so what happens is that when you remove the battery, right, the disc will drop instantly, right? It means that when we remove this, okay, this thing will no longer become an electromagnet, right? It will not become electromagnet, so it will become a magnetic material. So if you put two magnetic material together, right, it will not attract, then the disc will just drop off on its own. Then you cannot test out the strength of the electromagnet anymore, right? So in this case, right, let me put it in the form of written explanation. So without battery, there's no electricity flowing through, therefore the rod will not become an electromagnet and remain as an unmagnetized magnetic material. Basically, it just means that it will become a magnetic material. Okay, since the rod is not a magnet, it cannot attract the disc, they will just fall, okay? Or rather the disc will just fall. So in this case, right, if you replace the disc with a button magnet, right, so in this case, right, the rod, no battery, right? So it will just become a magnetic material, MM. Okay, so you replace the disc with a magnet. What happened, right, is that this thing, right, okay, the thing will not drop off. It will not drop off anymore. Because why? It will remain attracted, but you cannot test out the strength of the electromagnet anymore. Okay, so that's why it says will prevent the setup from working properly. Because this setup is to test the strength of the electromagnet, right? So in this case, if you replace the disc with a magnet, it will just remain attracted. Okay, that means no matter how much weight you put on it, right, it will not be able to test out the strength of the electromagnet. So how to really answer this part? You can just say the disc magnet will attract the rod and will not drop off when the battery is removed. Okay, in this part. Okay, so question number 42. Isabel tells Harvey that she's inside a dark room. Isabel is able to see Harvey clearly through the small window. However, Harvey cannot see her at all. Okay, so to be able to see something, right, the key idea is always about this. Light hitting on an object and reflected into someone's eyes. Okay, so let's take a look at this. Where is the light source? The light source is probably from here, from the sun. So what happened is that the light hit Harvey, okay, maybe into his head, and then it get reflected into the small window into her eyes. That's why she's able to see Harvey, okay, because there's light hitting into Harvey and get reflected into her eyes. So over here, right, so what properties of the material does the window have to allow Isabel to be able to see Harvey clearly? So what is this property over here? Can you see that I'm trying to draw a light ray that's passing through? So in this part, the property is most likely that the small window should be transparent, or it should allow most light pass through. That's why Isabel can see Harvey. So the main idea is this, okay? So transparent or allow most light pass through. So basically this is asking for an adjective. Okay, so what you should not write. Okay, so in this case, you should not write transparency. So how do you know that this is actually a wrong answer? So imagine you write this, okay, the window is transparency. It doesn't make sense, right? So over here, the window is actually a noun. The transparency is also a noun. So if you write these two together, right, it just doesn't make sense scientifically. Okay, so that's why this is wrong. Okay, but in fact, if you say something like this, the window is transparent, it does make sense because you are trying to say that the window itself, which is a noun, transparent is an adjective. So the adjective is added to the noun, in this case, which is the window. So that's why this question, right, I put it here, is asking for an adjective. You have to ask yourself, right, what property of the material does the window have? Is it asking for an adjective or is it asking for a noun? So there's always some clue in this question, okay, for you to actually look into. Okay, asking for adjective or noun. Okay, so over here, explain why Harvey is not able to see Isabel in the dark room. How come Harvey cannot see Isabel, but Isabel can see Harvey? So you take a look at this. The problem is that Isabel is in the dark room. Dark room, there's no light source. So there's no light source. So let me write this down. No light source. If there's no light source, right, there's nothing hitting onto Isabel and there's nothing reflected into Harvey's eyes. So imagine that if there's a light source, imagine there's a light source. So the light will hit into Isabel and then get reflected into Harvey's eyes. This is the ideal scenario that it should have happened if there's a light source in the dark room. Okay, but now the problem is there's no light source. So this is the problem. Okay, so how to answer for part B? We can go back into this idea over here. So we can say first, we can talk about this. Okay, there's no light source. There's no light source in the dark room. So therefore, there is no light reflecting from Isabel into Harvey's eyes. Harvey cannot see Isabel. Okay, so that is how you should have explained for part B. How come part B cannot see Isabel in the dark room? Okay, without moving their position, that means without moving Isabel or Harvey. Okay, you cannot talk about this. Okay, suggest one way such that Harvey can see Isabel through the window. Okay, now you know that for this, right, this is a problem. The problem is there is no light source. So what you should do, solve the problem. Add a torchlight. Okay, add a light source in the dark room. Then the blue color arrow would have happened. Okay, there will be light hitting Isabel, then there will be light reflected from Isabel into Harvey's eyes. Harvey can see Isabel. So for this part, put a light source in the dark room. Okay, so what you should not write, what should not be accepted if you write something like this. Okay, move Isabel closer to the window. Move Isabel closer to the window might allow Harvey to see Isabel, but this cannot be the answer. Why? Because they say without moving their position. They already say this part. Without moving. So you cannot write this part. Okay. So for this, right, this is the end of the paper. Okay, I'm going to review all the questions from question 1 all the way to 41. So you can pause, take some time to look at the correct answers. So question 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. This is the section B part. Okay, 29, 30, 31, 32, 33, 34, where the actual open-ended section starts, 35, 36, 37, 38, 39, 40, 41, 42. Okay, with that, thank you very much.